Trig, add page, we're going to do 2.3a. Secant and cosecant. All right, secant and cosecant. Now, at the start, it's going to be painful. After that, it's going to get really easy. Okay? So don't turn off the brain thinking this is way too hard for you on this first example. Okay? But let's say y equals the cosecant of x. Okay? All right. So the cosecant equals 1 over the sine of x, correct? So if we go 0, and if we go pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi for our x's. Okay? To graph the cosecant of x, we put 0 in for x. So that the cosecant is 0. Well, the cosecant of 0 is equal to 1 over the sine of 0. What's the sine of 0? What's the sine of 0? Come on, get your unit circles out if you don't know what the sine of 0 is. Sine of 0 is 0. What's 1 over 0? What's 1 divided by 0? Don't say 1 over 0 is 0. Everything is glorious in the world of math until someone tries to divide by 0. Because when you divide by 0, it is undefined. It's like fruit basket upset. Okay? It's undefined. We'll talk about this one in just a little bit. What happens at undefined? Okay, pi over 4. What's the sine of pi over 4? Square root 2 over 2, right? So it's 1 over square root 2 over 2, which is the same as 2 over square root 2, right? And can't leave square root 2 on the bottom, so we multiply top and bottom by square root 2 over 2. So it's 2 square root 2 over 2. 2's cancel, so it's just plain simple square root 2. So in the first chapter when we were figuring out all these, yeah, you need that for the second chapter. So what we learned in the first chapter is coming back to us. Okay. Pi over 2. What's the sine of pi over 2? 1. What's 1 divided by 1? 1. 3 pi over 4. What's the sine of 3 pi over 4? Square root 2 over 2. So it's the same answer as this, right? So just square root 2. What's the sine of pi? 0. What's 1 divided by 0? Thank goodness nobody said 0. Or I might have had an embolism, which is a bad heart attack. Okay. 5 pi over 4. Negative square root of 2. Because it's negative square root of 2 over 2 for the sine. So then the reciprocal of that is just negative square root of 2. 3 pi over 2. Negative 1. 7 pi over 2. How about negative square root of 2? Look at the pattern, man. Every other one is square root of 2.
No, I was saying like it was 7 pi over 4.
Oh, 7 pi over 4. Yeah, there you go. I was going, Brian Frias. You're a smart kid. What happened, man?
What?
You said 4, and I was going, what in my brain? I was going, what happened? But you were just correcting me. Yeah. No, you are like still a smart kid. Okay.
Yeah.
You're probably a smart kid that knows I don't want to pour concrete when I grow up, right? How's pouring concrete this weekend?
No, it kind of sucks.
Yeah. So, yeah. So that's why you go to school, so you don't have to pour concrete the rest of your life.
I guess, yeah, for sure.
Any concrete construction guys in here? No? No? None of these guys are? Some of my other guys, Trey Smith and those guys are. Yeah. I don't think they want to do that the rest of their lives. All right, 2 pi. 2 pi is the same as what? 0. What's secant of 0? Cosecant of 0? Undefined. All right. So, pi over 2, pi, 3 pi over 2, 2 pi. All right. So I'm going to start right at pi over 2. Whoa. Pi over 2 is 1. What is square root of 2 on your calculator? 1 point what?
1.4.
1.4. So if this is 1 and this is 2, 1.4 at pi over 4, because pi over 4 would be right there. 1.4 is about right there. And 3 pi over 4 is here. 1.4 is about right there. So it kind of goes like this. What does that remind you of? A smiley face. Yeah. Let's go more mathematical here from algebra 2. A parabola. Oh, remember those things. Yeah. So, I wonder what this undefined does to the graph. We can't graph at an undefined, can we? No. So back in algebra 2, way back in the day, some of you are in it right now, but way back in the day, you'd put what's called an asymptote in there, and this parabola approaches this asymptote. And there's an asymptote right here on the axis, so it approaches here. Okay? Now, 5 pi over 4 is negative square root of 2 over 2, which is negative 1.4. About right there. And 3 pi over 2 is negative 1. And then 5 pi over 4 is there. And 2 pi, we're going to be undefined, so we got another asymptote going on. So we've got another parabola going down like this. Okay? And there we go. Now, was that kind of sort of a lot of work? Okay. So this is Mr. Bierschbach's cheat code to this. Cheat code, yeah. So if you're told to find y equals 2 cosecant of x minus pi over 4 minus 1, okay? You're going, oh my, to find the points for that might be kind of difficult. Even though I could make it out on a chart like that, I could find the points. Mr. Bierschbach's cheat code. What you're going to do is go y equals 2 sine of x minus pi over 4 minus 1. Then draw parabolas. Okay? Then we're going to draw parabolas from that. Okay? So, let's see if we can do that. One, 2, 3, -1, -2, -3. Since it's pi over 4, we'll go 4 spaces to pi over 2, because that's a nice amount. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so I'm going to graph sine, and here's another way I do things, is I'll underline what I'm doing each step. So first step, I'm just going to do the sine of x. So I'm just going to underline that and go 0, 1, 0, -1, 0. Just like what we did last week. Okay? And then what's next? Well, you work from the front to the back, so now it's 2 sine of x. So I'm going to underline that in blue. What does the 2 do to it? It affects the amplitude. Makes it twice as high, twice as low. Twice as high, twice as low. Okay? Then, what does the minus pi over 4 do to it? Minus pi over 4, what does it do? Shifts it. Which direction? Left or right? Right, how far? Pi over 4, which is how many squares in this case? 2 squares to the right. 2 squares to the, put that one in the wrong spot, to the right. Okay? Then, the last step, of the sine curve is everything goes down by 1. Okay. So, asymptotes occur where? When you divide by 0. Okay? Now, you would say, well, then I need an asymptote right here, right by pi over 2, and right here, just past pi. And the answer is not so fast, my friends. Okay? It's when you divide by 0 of the tangent of the sine curve before you do any vertical shift. Okay? So, see on the orange graph. Okay, everybody's looking at the orange graph. Wherever the orange graph hits the x-axis, that's where there's going to be an asymptote. Wherever the orange graph hits the axis before the vertical shifts happens, that's where there's going to be an asymptote. Your asymptotes should always be the same spacing apart from each other. Okay? They should be equal spacings. You shouldn't have a skinny asymptote here and then a little later in your graph a really wide asymptote. Okay? They should all be equally spaced out, which we have here. Now, what was the last graph? Well, it was a purple graph, and I know it's kind of hard to see purple up there, but it was a purple graph. So in light blue, I'll draw my asymptotes from there. I said in light blue, computer, I'll draw my asymptotes from there. Then the actual answer is in blue. That's y equals 2 cosecant of x minus pi over 4 minus 1. So, you need to draw out the sine curve, or in some cases, the cosine curve, before you do anything else. Okay, so let's go to secant ones, because we kind of played with cosecant now. Let's go to secant ones. Now, let's look at the very basics of what does y equal secant of x look like? Well, what would you draw? What function would you draw if you're graphing secant? Cosine. Y equals cosine of x. All right, here we are. So, what's the cosine curve? Where does it start? 1, then it goes to 0, -1, 0, 1. Okay, when I'm doing secant, I like to go one past here because I like at least 2 asymptotes. And where do our asymptotes occur? Where the cosine is equal to 0. So you have your function, your cosine curve like this, and I'm going to finish it off to hit the x-axis there again. So then I'm going to throw on down some asymptotes right here, and right here, and right here. There's my asymptotes. Okay? And then in black, I'm going to put my secant curve, which is the parabola from here. So which direction should the parabola go from that black dot? Up or down? Down. Because we're below the x-axis, so it should go down like this. Oop. Shouldn't hit the line. Be careful not to hit the line. Go right up, sidle right up next to it. Now, what people have done in the past, and I've counted points off for them on their test when they take the test, is they'll graph their asymptotes like this. They'll go like that. Or their parabolas like that. What's wrong with that? Well, they're not that close to the asymptote. You got to be at least a little bit close to the asymptote for me to give you full credit. Okay? You might know you go up or down, but you got to get close. Okay? Okay. All right. So, these should give you no problem doing some of this. The ones that'll give you problems we'll cover in the second half. Okay? We'll cover in the second half. But I'm going to give you like 4 problems right now to do. And then we'll come back. I'll kind of maybe even go through a couple of them, make sure we're on the right track. And then in the second half, we're going to go through some period stuff. So on page number 135, page number 135, I want you, what are you doing, computer? I want you to do problems, numbers. We're going to do number 31, 35, and 43. That's good enough for now. If you do 3 problems over the next 20 some minutes, okay, and then I'll kind of maybe buzz through those really quick with you, and then we'll start throwing period in on this, which will make it a little more interesting, okay? But it shouldn't make it overly hard because you're kind of getting, hopefully, the gist of graphing down a little better. Okay, there you go.